So we have done already discussing with some of the preliminary concepts for calculus. We are done with functions and their graphs and also polynomial functions. Now today we're going to discuss about inverse of a function. So what do we mean by inverse of a function? Okay, so let's start with the definition of the inverse of a function. Let f be a one-to-one function with domain A and range B. Then its inverse function, denoted by this is read as f inverse, has domain B and range A and is defined by this equation. This is read as f inverse of y is equal to x if and only if f of x is equal to y for any y in B. So the assumption here is that we are given a one-to-one function. What do we mean by a one-to-one function? This means that no two different elements in the domain have the same element in the range, meaning every distinct element in the domain has exactly one element in the range. Notice also that um, the inverse function has domain B, which is B here is the range of the given function, and range A, and A is actually the domain of the given function. That's why, as you notice, f inverse of y is equal to x. Y here is actually an element in the range of the given function, which is now an element in the domain of the inverse function, and x is actually an element in the domain of f, which is now an element in the range of the inverse function. So f of x is equal to y. X is an element in the domain of A, and y is an element of the range in B. Okay? So suppose we have two sets, set A and set B. Set A consists of elements 1, 3, and 8. Set B consists of elements 5, 7, and negative 10. This is a one-to-one function because 1 corresponds to 5 only, 3 corresponds to 7, 8 corresponds to negative 10. However, here in the inverse function, notice that the input values, which is the domain of the inverse function, is actually the range of the given function, and the range of the inverse function is actually the domain of the given function. Okay? So, for example, suppose we have a one-to-one function with domain A is equal to 2, 3, negative 3, and 1/2, and it has a range B is equal to 8, negative 1, 5, and negative 9. So, f of 2 is equal to 8, meaning the function value, if you input 2, then you will have an output which is 8, which is also an element in the range. Now, the inverse of this is f inverse of 8 is equal to 2. Okay, notice 2 is an element in the domain of f, 8 is an element in the range of f, but here in the inverse function, 8, which is an element in the range of f, becomes an input value, meaning becomes an element in the domain of the f inverse, and 2 becomes 2, which is now an element in the range of f inverse, is actually an element in the domain of f. Okay, so f of 3 is equal to negative 1, which means that f inverse of negative 1 is equal to what? Is equal to 3. Sorry, this is 3. Okay, this is 3. Sorry. And this one, f of negative 3 is equal to 5. So this means that f inverse of 5 is equal to negative 3. Okay? So f of 1/2 is equal to negative 9 implies that f inverse of negative 9 is equal to 1/2. Okay, so Inverse of a function. Now, when can we say that the two functions f and g are inverse of each other? So we have here another definition. If the functions f and g satisfy the two conditions, then g of f of x is equal to x for every x in the domain of f, and f of g of y is equal to y for every y in the domain of g. Then we say that f is an inverse of g and g is an inverse of f, or that f and g are inverse functions. Okay? So for us to say that f is an inverse of g and g is an inverse of f, we have to satisfy these two conditions. Okay? So we can say that f is an inverse of g if we can write g of f of x is equal to x for every x in the domain of f. And we can also say that g is an inverse of f, okay, provided that f of g of y is equal to y for every y in the domain of g. So we have here an example or examples for us to understand this def definition. So for example, let f of x is equal to x cubed plus 1 and g of y is equal to cube root of what? Cube root of y minus 1. Okay? Now, take note that if we are going to get f of gy, okay, f of gy, so this is now a composite function, f of gy, meaning the input values or expressions is actually the gy function. Gy. So, meaning, whatever our gy, we have to input this one to our f. So, since our f is x cubed plus 1, then we input our gy. Our gy is cube root of y minus 1. You input that one to the variable x in our f. So, this becomes raised to 3 plus 1. Okay? Now, cube root of y minus 1 raised to 3. So this will be cancelled out. So we have y minus 1. And there is plus 1 here. So y minus 1 plus 1 is equal to y. So we have f of f inverse of y is equal to y. So we have written that our f of gy is equal to y. So our condition, the one of the conditions for us to say that f and g are inverse of each other is satisfied. Okay, next one. G of f of x. What is our g of f of x? This one. G of y is this. So our f of x, which is x cubed plus 1, will be, we have to input our f of x to our g of y. Note that the variable here, the independent variable is y. So f of x, where is f of x? X cubed plus 1. So this x cubed plus 1, okay, will be substituted to the variable y. So cube root of x cubed plus 1 minus 1. Okay, then simplify. So we have equal to cube root of x cubed plus 1 minus 1. Now, 1 minus 1 is 0, so we have cube root of x cubed. This will be cancelled, so we have x. This implies that f inverse of f of x is equal to x. Hence, the two conditions for us to say that they are inverse of each other are satisfied. Therefore, f and g are inverse functions. Okay? So here, we are changing the independent variable. So another notation, we introduce this one, another notation. So f inverse of f of x is equal to x for every x in the domain of f. So this is the first condition, that if we can write f inverse of f of x to be x, then that condition is already satisfied. Then proceed to the second condition, that f of f inverse of y is equal to y for every y in the domain of f inverse. So the second condition is also satisfied. But we can also change the variable. For example, um, in this case, this first condition is not changed. So f inverse of f of x equal to x. So here, f inverse of f of x is equal to x for every x in the domain of f. Okay? So notice that from here, uh, it is y, but actually it's just the same as long as the variable is in the domain of f inverse. So we have f of f inverse of x is equal to x for every x in the domain of f inverse. Okay, so the point here is that um, if we can rewrite, or if we can satisfy the two conditions, whether these conditions or these conditions, then we can say that the two functions f and g are inverse functions. So for example, the inverse of f of x is equal to 3x is this one. F inverse of x is equal to 1/3 x. You have to show why is it that f of x equal to 3x has an inverse which is 1/3 x. So show by satisfying the two conditions. So letter B, the inverse g of x, which is equal to x cubed, is g inverse of x is equal to x raised to 1/3. Again, we have to satisfy this one by satisfying the two conditions. Then letter C, if f of 3 is equal to 5, then f inverse of 5 is equal to what? If f of 3 is equal to 5, then f inverse of 5 is equal to 1. Okay, are you ready? So we have the solution. First, we are going to show that the inverse function of 3x is 1/3 x. How? So we start with f inverse of f of x. So we have to show that f inverse of f of x is equal to x. And f of f inverse is equal to x. Okay, start. F inverse of f of x. So this is our f inverse, which is 1/3, right? So since our f of x is 3x, so all we have to do, this 3x will be substituted to the variable in f inverse. So 1/3 of 3x, and since 3 will be cancelled, so this is x. So the first condition is satisfied. Next, we have to satisfy f of f inverse of x. Now f, 3x, so 3, and we have to substitute our f inverse of x to our f. So our f inverse is 1/3 x. So this will be substituted to the variable of f. So 1/3 x. And since 3 is just equal to 1, 3 over 3 is 1, then we have x. Therefore, the two conditions are satisfied. F inverse of f of x is equal to x, and f of f inverse of x is equal to x. Okay? So we can say, and we have shown that f and f inverse, this one, the two functions are inverse functions, or they are inverse of each other. How about letter B? We have to satisfy that g inverse of g of x, okay, is equal to what? G inverse of g of x. Our g of x is x cubed. So we have to input x cubed to g inverse. So x cubed raised to 1/3. Okay, this will be equal to 1, so we have x. G of g inverse of x. So our g inverse of x, okay, take note this G inverse of x, this is x raised to 1/3, okay, will be substituted to the variable in our G. So, G inverse of x is x raised to 1/3 raised to 3. And this is equal to 1. The exponent is just equal to 1 because 3 over 3 is 1. So we have x. Therefore, we have satisfied the two conditions. Hence, we can say that the two functions are inverse functions. Okay? So letter C. If f of 3 is equal to 5, then f inverse of 5 is equal to what? It is equal to 3. Okay? So that is how um, we satisfy and how we show that the two functions are inverse of each other. So hope you learned from this video, and don't forget to share the learning that you've got from this video. Thank you so much, and God bless.